Hello friends, welcome to my channel. Let's have a look at problem 2333 again together. Minimum sum of squared difference. So the problem here is asking to minimize the L2 distance square for two integer vectors nums1 and nums2. In a previous video, we shared a solution using the concept buckets from bucket sort. And in the current video, we're going to share another format of solution using sorted containers. So here we are using sorted dictionary. The idea remains the same. So we count the frequencies of the absolute differences in the coordinates, and we shrink the absolute differences from large to small. The key observation is the following. We do not need to consider the increment or decrement details. So we just need to be aware that there are at most k1 plus k2 times of such operations we could do. So here is an example which we cooked up from example 2 by changing k1 and k2. So for these two vectors, nums1 and nums2, the absolute difference is 4, 4, 4, 3. Therefore, the counts are 3 one time and 4 3 times. And the allowed operation is 2 plus 3, that is 5. So then we began to do the shrinkage. So at the very beginning, so the largest gap is 4. So we try to shrink this 4 to be 3. So we have 5 allowed operations, and the frequency of 4 is 3. So we can shrink all the 3 instances of 4 by 1. As a result, the gap for 4 disappears. So in other words, its frequency is 0. And due to the shrinkage, we produces another 3 gap 3. So the total count for the gap 3 is the original one plus the 3 we produced, that is 4. So now the sorted dictionary contains the gap 3 with frequency 4. So it's also the largest for sure. So we have 2 allowed operations. So because originally we have 5 and we use a 3 in the first step. So now when we do the shrinkage, we can do the shrinkage for 2 instances of the gap 3 out of the 4. So as such, the frequency for gap 3 is decremented by 2. So now the frequency for 3 is 2. And due to the shrinkage, we produces another gap, that is 2, with frequency 2. So this is the final state for the sorted dictionary. Then if we add the gap square times their frequency together, we're going to get 26 for this problem. So that's a quick walkthrough for this problem. So now let's look at our solution in this video. So I first imported the sorted dictionary. The purpose of using sorted dictionary is to pick the largest absolute difference. So with that said, let's do the process. First, I'm going to track the information for the length or the dimension of the two vectors. And then let's look at the absolute difference. That's what we are interested in. So absolute value of x minus y for xy in zip nums1, nums2. So we are only interested in those with those absolute difference that are not equal to 0. So with that said, we want to make a sorted dictionary out of the frequency counts. For counting the frequency, basically it's collections counter, the absolute difference, and then we can make it a sorted dictionary. So let's call this variable abs diff count. So once this is done, we're going to do the procedure. So let's first track how many allowed operations we have, that is k equals k1 plus k2. So next we're going to do the actual work. So basically it's a while loop, while abs diff count is not empty, and abs diff count, so we want to pick the element. So we want to see if the frequency is greater than 0, and also we want to make sure we have available operations. So if this was the case, first I'm going to get the absolute difference as its count. So that is abs diff count, so pop atom. Then we want to examine how many operations we can do with this absolute difference. So for this, we are going to introduce a temporary variable, and the allowed operations we can do to this absolute difference is the mean of count at k, right? Then basically we shrink temp number of the abs diff by 1, right? So then we are going to consider this situation. If count minus temp is greater than 0, so in other words, after this number of shrinkage, the abs diff gap still exists, then we should add this back to the dictionary. So basically abs diff count, abs diff equals count minus temp. So otherwise, if it's 0, then this key just disappears. So next one is that we produced this new gap, that is the absolute difference minus 1. So if it were 0, so we are basically achieving optimal state. If it's greater than 0, so we should update the frequency for this gap. So for this, we're going to do the reset abs diff count abs diff minus 1. Then it's possible that this gap is originally in the dictionary, right? First we track that information, abs diff count get abs diff minus 1 or 0. So this get function gets a frequency for this gap. If this key or this gap is not in the dictionary, the count we set it as 0. Then the reset will ending the temp. So that's about it for the operations for the keys. Then we need to update the allowed operations we have, that is decremented by this temp variable. So with that said, we are done the shrinkage procedure. So what remains is to return the result. So we're going to return the sum of the count times diff square for diff count in abs diff count items. So we can add this diff greater than 0. So this we cannot this is not absolutely necessary because the things in the dictionary is not 0. With that said, let's first do a special case check. This passes the example we cooked up. So now it's time to do a generic case check. Yeah, it passes the generic case. I guess that's about it for this problem. As we mentioned, the main purpose of using sorted dictionary for this format of solution is that with it we can pick conveniently the largest gap, and we can shrink from there. That's about it. Thank you very much.